All right, good morning, everyone. Welcome to the April Water Conditions Monitoring Committee meeting. My name is Emily Adrid. I am the Water Planning and Climate Impact Specialist at the Colorado Water Conservation Board. Today, we are going to have a report from the Colorado Climate Center and RCS, and then a report from the Colorado Airborne Snowpack Monitoring Program, or CASM. So we have a good lineup today. Before we get into things, I just wanted to note that our next meeting in May is going to have a hybrid option at the CSU Spur Hydro Building, specifically the Confluence Theater in May. So it'll still be online for those of you who want to be online, but if you're in the Denver area, and you'd like to come see us in person, we will be at the CSU Spur campus. So we're really excited about that, and I will be sending out more details on that in the coming weeks, but wanted to make that note for everybody. And with that, if you all want to put your name and affiliation in the chat, that would be great. And I think I'll stop sharing my screen now. We have Peter Goebel. I think I made you the co-host, Peter. Want to start us off?
Yeah, sure. Let me see if I can share my screen here. All right, let's see. You should hopefully be seeing things in present mode now. How are we looking?
Yep, looks good. Thanks.
Perfect. Thanks so much for having me on this morning. Thanks for everyone for joining this morning. For those who may not have met me, my name is Peter Goebel. I work with the Colorado Climate Center at Colorado State University. And today I'll be giving our climate conditions update across the state, as well as giving a short drought update and an outlook for what we might expect with the remainder of this spring in 2024 and what we might expect going forward for summer 2024. So this is the outline of the agenda that I just went over. Pretty standard agenda from our group. All right, we'll start with a look at temperature and precipitation for the first quarter of the calendar year 2024. So this is looking at how we fared January through March. We'll touch on what's happened in the first several weeks of April in just a few slides here, but here we're looking at what we call a quadrant chart, where each circle represents 1 year of data. The horizontal or x-axis here is showing us precipitation. Further you are to the left, the drier it is, the further to the right, the wetter it is. The vertical axis here is showing us average temperature across the state. And these data come from the National Centers for Environmental Information Enclime Grid product. We can see that each dot represents a given year, with the star being 2024. And the dashed lines show us our recent averages, or the average temperature with the horizontal dot line, and the average precipitation in the vertical dot line for 1991 through 2020. And we can see we're in what's called the warm and wet quadrant for the first quarter of the year 2024. Statewide, we've been well above average for precipitation, largely driven by a really nice February. Although in some areas, March was also quite wet. We certainly had a large snow event the second week going into the third week of March. Here's how things look from a temperature standpoint statewide. This is looking at all 130 years of data in the Enclime Grid dataset and seeing how this most recent year, 2024, ranks compared to other years on record. And here we are looking at just March of 2024. Areas in the really light red are areas where we were at least 35th warmest on record out of that 130-year data set. The darker shading that you see a lot of over the San Juans is top 20, and then that really dark shading where Saguache County meets Gunnison County is where we had a March in the top 10 warmest on record. Most of the state is in that kind of average range throughout the entire historical distribution, which is arguably a bit cooler than average if we look at our most recent years, since conditions have warmed over time. I think if we put this, yeah, here we can see on the next slide, if we put this March in the context of the last 40 or so years, it was pretty average. So if you were to kind of draw a horizontal line over here for the last 40 years, our 2024 temperature, it would be right through the center of that portion of the data. Certainly much warmer than last March, but much cooler than some of our recent warm Marches like 2017. All right, here's a look at the first 3 months of the calendar year. And this is showing that most of the state is in that 35th to 20th warmest on record range, with much of the west slopes, even in the top 20 or top 10. However, if we again look at the full time series, and again, this is averaged across the state, we see that over the last 40 or so years, this January through March wouldn't have been that much out of the average. And this kind of stands to reason because January was cooler than normal with a nice cold snap right around Martin Luther King Day. February was warmer than normal, and then March was kind of more near normal. So it makes sense that we end up a little bit more near normal when you average all that together. This is a look at the last 12 months. So April of last year, 2023, through March 2024. And here we see much more of the state in the top 20 warmest, and a lot of the state in the top 10 warmest out of that 130-year record. And a lot of this really goes back to just how warm the late summer and fall was. We had quite a mild fall all the way through November, and that definitely impacted these numbers statewide. And then this is what we saw for the first part of April. One thing I will say about this only goes through the 19th, which is kind of right at the start of our recent cold snap that you experienced over the weekend. And in some cases, the data that are in this graphic might not even be updated for the last couple of days of that period. So I do expect some of these areas where you see warmer colors that you can see from the scale on the right-hand side show us above normal temperatures for April so far, that these numbers will kind of revert to the mean a little bit, or not be as much of a warm anomaly once we factor in some of the cold conditions that we experienced over the weekend. There were some areas even at lower elevations that didn't get out of the mid 30s on days like Saturday. And then we had some really cool temperatures the morning of Sunday the 21st. So this is now we're shifting gears to precipitation. Again, we'll start with just March and then kind of zoom out from there. But we see that March of 2024, for much of the central portion of the state, ranked in the top 20 out of that 130-year record. And in some cases, even as high as top 10. And then much of the West Slopes didn't quite make the top 20, but at least the top 35 out of that 130-year record. We did have, as I mentioned previously, a significant snowfall event on March 14th into March 15th of this last month. Areas west of Boulder and west of Denver were measuring snow by the foot, in some cases as much as 4 to 5 feet. But this, the influence of this storm was largely terrain driven, meaning that the influence didn't extend as nicely out onto the eastern plains as we would have liked to see. There was some moisture, but not nearly as much as closer to the mountains. And we can see that there are areas of the eastern plains that were drier than normal in March, and that's going to factor in when we start looking at some of our drought maps here in just a few slides. Okay, here we're looking at March precipitation averaged across the state in terms of a time series. And we can see, yes, statewide, it was above normal, and it was our wettest since 2019, which was one of our wettest on record. And comparing to the last 30 or so years of data, 30, 40 years of data, definitely above average for March. Okay, here we are looking at, again, January through March, or the first quarter of the calendar year. And this is showing a similar pattern to what we saw for just March, but you can see that the warmer contours actually extend a little bit further out onto the plains, certainly not all the way out to the eastern border, nor do they extend out to the western border, but we see more area in the top 20 or even top 10. And that's largely driven by the fact that I mentioned earlier, for a significant chunk of the state, especially immediately east of the Continental Divide, but also some areas in the northern Rockies, the month of February was significantly wetter than normal. It was an interesting combination of warm and wet in February, and you really see that footprint in some of these graphics, including the quadrant chart that I led with up front. And then here is a look at percent of normal precipitation for the month to date. For the most part, April has been dry. We have seen in the last week things recover a little bit in the northern Rockies, as well as immediately east of the Rockies on the Front Range and kind of the South Platte River Basin. But further to the south and further to the west, and even further to the east, it's been a drier month. Hopefully some moisture on the way to help with that a little bit, but probably not enough to get us back to normal or above normal, I would guess, statewide. Here is a look at the time series for January through March. Probably should have flopped this with the last slide, but again, you see in the overall context of this 130-year record, a well above normal January through March, but certainly drier later. Okay, this is a look at the last 12 months. So here we see that the biggest influence on the last 12 months was in fact what happened last May through July for eastern Colorado, particularly areas just east of the metro area are still showing a record wet April through July, largely because we really nailed our wet season last year. Our wet season in that area does tend to be May, June, July, and May, June, July were much wetter than even normal. And so you really see that footprint still hanging around there. Once you look at the west slopes, if we were to do, say, an 18-month kind of long-term precipitation record, things would look a lot better, because 2023 was a better than normal snowpack year for much of the west slopes, particularly as you get to some of these regions that show up dry on the 12-month time scale further towards the western border of the state. Some of those areas even had record wet snowpack in 2023. And as a result of that, I think you'll see in NRCS's talk later, I think we're still holding on to some pretty good water supplies in some of these areas that are showing drier than normal on the 12-month time scale. But things certainly drier recently. And when we show these 12-month depictions here in a couple months for eastern Colorado, who knows what they'll look like, because you start to lose the memory of last spring and summer. We've had a few significant wind events over the month of April, particularly April 6th into April 7th. This is a graphic showing the maximum wind gusts from both April 6th and April 7th from the COAGMET network. It's worth keeping in mind that these COAGMET stations are mostly only 2 meters above the ground, whereas usually when the National Weather Service is reporting wind gusts, they're reporting them at 10 meters. And the further off the ground you are, the more free the wind is to blow quickly. And so for the most part, if you're converting 2-meter winds to 10-meter winds, you're probably looking at a multiplication factor of something like 1.2 to 1.3, depends on the roughness of the surface. So this observation in the Boulder area of 75 miles per hour on April 6th, if you were to apply that kind of a multiplication factor, it comes up closer to 100 miles per hour. And some of these significant winds that we saw on the Eastern Plains next day that you're looking at anywhere from 45 to close to 60 miles per hour. You're looking at more, say, the 60 to 70 mile per hour range once you apply that multiplication factor. I don't work in my office that often these days, but the week before I had been working in the office, and I remembered to close the window, but I did not remember to lock it. And so when these significant gusts came through, some damage in my office on the atmospheric science campus there. Okay, this is a look at some of the other weather that we experienced throughout the month of April so far. This is just a look at some of our snow totals from the snowfall Friday into Saturday from the Community Collaborative Rain, Hail, and Snow Network, or COCORAS, around the metro area, where we were sort of surprised in some areas with as much as a foot of snow west of the metro area, but then a good swath of 6 to 9 inches somewhere in that area, cutting right through the northern portion of the metro area. Most areas didn't get quite that wet with the last snowstorm. This graphic in the upper right is showing temperatures for the water year to date for Boulder. And here, if you're reading this graphic, the kind of brown range is the normal range. You'd expect that to go down through winter, up again in the summer. The red line and blue line show the record for each date, and then the shaded areas kind of show above and below normal area. And we can see that throughout this cold snap this weekend, we were well below normal for much of the northern front range, not even getting out of really the mid 30s and having low temperatures down into the mid to low 20s. Okay, so with that, I'm going to go ahead and move into some of our drought updates. So this is a look at the U.S. Drought Monitor most recent map. So this is valid as of April 16th, and it was released on April 18th. And we can see that for a lot of the state, we are still holding on to no drought designation. That's great. We've got two significantly sized areas that are being marked by the U.S. Drought Monitor as abnormally dry. One of those areas being in southwest and western Colorado, the other area being in eastern Colorado. However, we are still in pretty good shape in terms of the fact that only 2.77% of the state actually has a D1 or worse designation, versus you would expect that number on average to be 20% or so. And the D1 that we do have, it's in western Colorado and in southern Colorado, a couple little splotches there. Here's how things have changed on the U.S. Drought Monitor over the last 12 weeks, or about the last 3 months, which is roughly the time scale that we spent a lot of the first 12, 15 or so minutes of this presentation looking at. And areas in green are areas where the drought designation has improved. Areas in yellow are where it's degraded one class. Areas in gray are where we've seen no change. Some of the areas that we've seen the best changes, up in the Northern Rockies, in both the headwaters of kind of the Poudre River, as well as more towards the headwaters of the North Platte, up in that area in Jackson County. We see that conditions improved by as much as 3 classes. This is largely due to the fact that snowpack started way below normal in this area, but was able to catch up in the months of January, February, and March. And then the San Luis Valley, we also saw improving moisture starting about the middle of January and through February. That has brought things back up as much as 3 classes in some areas. And this is how things have changed over the last year. So if we look at the west slopes, where we see that there's been degradations, if we think back to where we were a year ago on the west slopes, it was basically entirely drought-free after what was a really good snowpack year. So where we see degradations, that's from just 0 drought to D0 or D1. And then if we look at eastern Colorado, if we think back to where we were a year ago, there were some areas of the plains and of the kind of I-25 corridor near Pueblo that were in significant drought at this time last year. But if we remember back to what happened in May, June, July of 2023, basically all that drought was wiped off the map during that wetter time period. Okay, here's a look at a modeled representation of soil moisture. It's showing the entire contiguous US, so you've got to kind of zoom in on Colorado here. But this is looking at the percentile for top 2 meter soil moisture from the NASA Sport Land Information System model. And we can see that most of the state of Colorado is showing near normal or above normal soil moisture for different reasons, which I'll get into here. But then there's quite a bit of the state that's showing normal level soil moisture, or this 30th to 70th percentile range. And then we have areas towards the eastern end of the state that are starting to show below normal soil moisture again, as well as some of our areas on the west slope. Now, when I said there's a couple different reasons why you might be seeing above normal soil moisture in Colorado, we'll start with kind of the east side of the Continental Divide, where conditions have by and large been wetter than normal to start this calendar year. And you're seeing that some of those blue colors are showing up where we've had better than normal moisture. But if you look at the high elevations, you are seeing some areas that are potentially showing above normal soil moisture due to earlier than normal soil moisture recharge from snowpack. And I'm sure NRCS will get into some of the snow melt rates that we've seen so far and how that might be contributing to the soils in the high country. All right, so that is our drought update. Now we'll shift gears for the final part of my talk this morning, where we're looking at how we might expect things to change in the coming months based on the upcoming forecast for the next couple weeks, as well as perhaps more importantly, the seasonal forecast looking at what might happen in May through July, as well as even a glimpse out at late summer and fall. All right, so we'll start with just the next 7 days of weather. So this is based on numerical model output, and here we're looking at a map of precipitation, forecasted precipitation anomalies over the next 7 days. Valid, or let's see, shoot, this is actually, this is unfortunately a week old. I'll have to get an updated map and show that to you later. Let's hope that some of these other slides are updated. Okay, they are. I can speak briefly on the next 7 days. It does look like we'll have some moisture coming in this weekend, and it does look like it probably does favor the Northern Rockies as well as the eastern side of Colorado. So it makes sense that I was fooled by this old map, because we could see a little bit of a repeat of that, but it looks like perhaps more moisture coming in this weekend. I think that the above normal this time, it may extend a little bit further south than this if we're looking at the eastern side of Colorado. So hopefully do a little bit better there. This is looking at the 8 to 14 day time scale, where you can still get some skill looking at numerical weather prediction, especially if you look at kind of an ensemble of models where you look at the range of possibilities. What we're seeing here is that it's likely that a kind of warmer high pressure system will build in over the south and east US that's going to bring above normal temperatures to a lot of the central and eastern portions of the US, whereas we will still have low pressure and some moisture offshore to the west, and likely some of that will get spread across the northern United States over that 8 to 14 day time period. If we look at the precipitation map here for the 8 to 14 day time period, the green shaded areas are where we have an increased probability of above normal moisture kind of for that first week of May. For one thing, it doesn't look especially cool, as you can kind of see if you look at the temperature map. So I would be a little bit surprised if this falls as snow at lower elevations. But also, I am still a little bit skeptical of this area that connects the increased probability of above normal moisture in Texas to the increased probability up in the Dakotas and Montana and Minnesota. Models are still pretty split on this. The moisture for the 8 to 14 day time period could still quite easily miss us to the north. So I'm a little bit more sold on the fact that we'll have some nice, warm, mild days over this time period than the fact that when the moisture does come through, it's going to really deliver for eastern Colorado. It's possible, but still pretty split on, if that moisture misses us north or not. All right, so once you move beyond the 8 to 14 day time scale, you start having to rely on statistical relationships between how the atmosphere behaves and some of the slower moving components of the Earth's climate system, like what's going on over the ocean surface and the land surface. And particularly when we talk about this, we are often talking about the ocean, and we are often talking about El Nino versus La Nina, or what's going on over the equatorial Pacific Ocean, because that has semi-predictable ripple effects on the atmosphere globally. So this is a pattern of sea surface temperature, or this is the current pattern of sea surface temperature anomalies across the globe. If we focus in on the equatorial Pacific, we see that most of the eastern equatorial Pacific is still showing above normal sea surface temperatures, which is the calling card of El Nino, but we know that El Nino is quickly fizzling out and being replaced by La Nina. And we can see that cold tongue of moisture off of the coast of South America starting to develop. Most models show this continuing to intensify and then spreading across the eastern equatorial Pacific. And that is important for us here in Colorado because it impacts our precipitation. So when you have La Nina in place, it tends to strengthen the jet stream in the northern hemisphere and move it further to the north, versus when the tropical trade winds are weaker, you tend to see the jet stream in the northern hemisphere be a little bit weaker as well, but also meander more, and we have a higher potential for some of those good Colorado lows or four corner cutoff lows, whatever you want to call it, that can give us that really good Pacific and Gulf of Mexico moisture. And the proof is in the pudding here. This is a correlation analysis by season showing whether El Nino tends to be wetter or La Nina tends to be wetter in the state of Colorado by season. So in December, January, February, or winter, the northern and central Rockies, it's actually preferred to have La Nina because you have a little bit more regular storm activity, versus out on the eastern plains tends to prefer El Nino, more likely to get some of those events with low pressure further to the south that wrap around moisture. Once we get into the spring, basically the whole state for spring, summer, and fall are wetter during El Nino. So the fact that we have a La Nina developing tends to push things in the direction of more likely to be drier than normal. So this is the El Nino La Nina forecast going forward. Right now we have El Nino in place, but if you look at by season, how that might change, once we get out to, say, June, July, August, or our summer months, there's almost a 60% probability that La Nina will already be in place. And if it's not by then, it'll not be El Nino anymore. It'll be neutral conditions. And by the time we get out to fall, there's upwards of 80 to 90% chance that we'll have a La Nina in place. All right, with all that in mind, here are some of the seasonal outlooks from the Climate Prediction Center. And here we're looking at, on the left-hand side, the seasonal temperature outlook for May, June, July 2024. And on the right-hand side, the seasonal precipitation outlook for May, June, July 2024. The areas on the left-hand map where you're seeing these oranges and reds are areas where you have an increased probability of above normal temperatures, and that's with respect to the 1991 through 2020 normals, so recent normals. This is based on a couple things, but I think that most importantly, it is based on the trend that we're seeing with our warming climate, especially in summer. You're more likely than not in most places, unless you have some kind of signal from a statistical or dynamical model to really counteract it, to end up with warmer than normal conditions. We see more often in winter, where things are more variable, that there might be a signal strong enough to counteract the trend. But in summer, where the year-to-year variability is lower, if you have a trend towards warmer temperatures, you're just more likely to see that year in and year out. But also, if we look over on the right-hand side, we start to see an increased probability of below normal precipitation also creeping into parts of Colorado. We do have a good portion of the state in that's not shaded in any color. It's equal chances or equally clueless, as we like to call it. If we look at the month of May, I still think we have a pretty good shot at normal or even perhaps above normal moisture for May. But once you get into uh, late June and then even July, August, the effect of La Nina really starts to increase. But also looking at some of these climate prediction center models, we're seeing that the dynamical models are generally showing that we have an increased probability of a less active than normal monsoon this coming year. And that really takes effect when you look at the June, July, August seasonal forecasts. So for some of the same reasons that I was talking about earlier with our overall trend towards warmer than normal temperatures and the fact that summer is the least interannually variable season in terms of temperatures, or in other words, the difference between a warm summer and a cool summer tends to be less than the difference between a warm winter and a cool winter. If you have a trend moving in one direction, that tends to make it more so that there's a higher percent chance that you'll be above normal. But then also, if we take into account the influence of La Nina and some of these dynamical models that show an increased probability of a less than normally active monsoon, we see the confidence increase for June, July, August of a below normal precipitation type summer. Unfortunately, this also persists into the fall. So once we get into the fall, it's not just trend if we look at the temperature outlook, because once you get into the fall season, you do have more interannual variability. However, the probability of La Nina being in place by that time of year, mixed with the fact that La Nina is correlated with not only drier, but also warmer fall seasons, you get that this increased probability of above normal temperature stays in place throughout the fall. And then the increased probability of below normal precipitation stays in place through the fall. So if you mix together the fact that we have this increased tilt towards above normal temperatures and below normal precipitation for both summer and fall, and that the models haven't really been wavering on this for a while, you start to generate some concern. Thankfully, we are in a position based on having a decent snowpack this year and decent precipitation this year, as well as a nice wet spring and summer last year and a good snowpack last year. A lot of our water supplies are in a situation where we could potentially endure this type of a forecast. Another piece of good news is that because we have decent water supplies now, decent snowpack now, decent soil moisture now, the month of June fire weather outlook is still showing as normal. And I do think that this makes sense in spite of the forecast where we're looking at June when we have elevated probability of fire weather potential. That's usually because the snowpack is low and the mountains are going to burn through their moisture reserves in the soils and kind of in your vegetative fuels before we get into monsoon season. And if you look at years like 2002, 2012, 2018, June is typically our big fire window. But if you think about the outlying year of 2020, when we had our three largest fires in the state's history all occur in the later months due to a failed monsoon, which is potentially in the offing based on these seasonal forecast models, it's definitely something to keep an eye on later into the season, where if that does not change and we end up with kind of these longer term wet conditions, building fuels, and then shorter term warm, dry conditions, we could end up seeing these fire outlooks change later in the year. So definitely something to keep an eye on. Hopefully these seasonal forecast models turn out to be wrong and we end up with a good summer, but we'll see. Okay, so our overall takeaways today, this cool season this year, kind of, not just January through March like I showed, but really the whole winter into early spring season. milder than normal, but also wetter than normal statewide. So the wetter than normal, generally good news when we get that in the winter. Long-term precipitation anomalies, generally positive. When I'm saying long-term, I'm thinking of the 12-month time scale. If you look at eastern Colorado and still having some better than normal water supplies from what we saw last year, but then also if we think about the good snowpack we had in 2023 combined with a decent snowpack in 2024, some good water supplies out west as well. And that's a good thing because our seasonal forecast models do show us a pretty pessimistic story with both a potentially warm, dry summer and a warm, dry fall in the offing currently. We'll see how that all shapes up, but these seasonal forecasts are largely based on one, a shift to La Nina, two, the fact that climate change is driving our temperatures warmer in all seasons, but most predictably in summer, and then also some of these dynamical models showing a weaker than normal monsoon. One kind of more pessimistic note I have at the bottom here, the last year where we saw a rapid shift to La Nina during spring into summer, when we had these kinds of near normal snowpack conditions in April, it turned out to be 2020, which was the year that we had those big fires. Again, I in no way think that a repeat of 2020 is a guarantee, just something to keep an eye on. Another kind of analog year or a similar year where we were in a situation with better longer term water supplies and a decent snowpack, but then things rapidly shifted to La Nina during summer was 2000, which was the start of course, a bad drought. So we're definitely going to have to keep an eye on this going forward. All right, so that's all I have. Thanks so much for your time. And with that, I think I will pass it back to Emily, but if there's any questions, I'd be happy to take those now. All right, great.
Yeah, thanks. Cool. We'll be on the lookout for the La Nina. Thanks for the update. Okay, next we have Brian. And I believe you are a co-host. Hey, Brian, we can see your screen. I don't know if you're still on mute though.
Forgive me. Yes, I was on mute. Can you hear me now?
Yeah, we can hear you.
Okay, great. Thank you. Appreciate it, Emily. All right. Going to get started and then build on a few things Peter just mentioned. We are starting to see some melt. I shouldn't say we're just starting to see. We've already seen a fair amount of melt at some of the lower elevation sites in the southwest and western portion of the state. But I'll go ahead and get into that here now. So starting off with the time series of snowpack that we've seen this year. Snowpack actually was relatively close to normal statewide. Of course, the story is a bit different when you start to focus in on certain areas of the state, but with this particular graphic, we'll focus on just statewide snowpack. The median line, which is this smoother green line, is the percent of normal or percent of median that we typically compare to across the majority of the year. With the exception of towards peak season, there is the average of the historical peaks or the analog peaks, and we use that because it's a little bit of a better representation of that actual peak. So that is represented by that green X that is almost always higher than the median line here. So you'll hear me kind of refer to that They are quite different, and they look different on this map, but realistically, they're pretty close to the same. And I have expressed those values in a few different locations here in this presentation, and you'll see that things wind up being somewhat similar. In terms of giving a representation of where this year's snowpack sits with respect to median, the median line throughout the year, and then the average of the peaks. So you can see that through much of the year, when looking at the state as a whole, snowpack was, at least at first, below normal, but thanks to those storms in January, late January, early February, we did see a pretty good boost that really got us much closer to normal here across the majority of Colorado. And then for the majority of February, March, and much of April, we actually saw near to above normal precipitation in most parts of Colorado. And I'll break that down here in a little bit. And then, as Peter referred to, there was the late March set of storms, and really, in a way, it kind of persisted through March into early April that continued to keep our snowpack riding high and collecting at a near normal rate. So the mixture of those storms in late January and late March really wound up helping out much of the snowpack. I mean, as Peter mentioned, we did have a good February. And which you can see right in here, which really helped out and kept things near normal. So, but before that, we were looking relatively dry. I'm throwing a few analogs on there. You can see where snowpack is right now. We compare closely to kind of 2020, 2010, 2006, and 2001. And you can see that some of those lines do wind up showing a relatively steeper snowpack decline. I'm going to go back a slide here. You can see compared to the median line that we're exceeding those melt levels, those melt rates. So the melt rates is basically the decline here, the downward slope of these lines. And that is the melt rate. This green line is the standard melt rate for this time of year. And the black line is what's happening this year. So we are starting to see snowpack melt off a little bit quicker and earlier than normal, but it's not way out of the realm of normal. But again, we're looking at just the entire state of Colorado here, and we should break things down a little bit more to help explain what's going on elsewhere in the state, or around the state, I should say. So I'm going to kind of reel back a few months. I'm going to go to the beginning of January here. Statewide, at the beginning of January, as I kind of alluded to earlier, snowpack was not looking very good. We were below normal across the entirety of the state, largely at 68% of normal. Then we got those January storms, which those storms really tended to hit the northern portion of the state. There was some improvements to the southern, but the northern realized the real benefits of that storm. And we boosted all the way up to 92% on the 22nd of January. Fast forward a little bit more to those mid-January storms. Before those storms started on March 13th, snowpack had improved steadily through February, as Peter mentioned, but we got a pretty solid storm that really boosted things across much of the state through January. But when we actually experienced those storms in mid-March through the end or the beginning of April, we really saw a great boost in the southern half of the state, where snowpack wound up being statewide at 107% of normal. So a big boost there. Sorry, I'm going to go back one slide. We were at 97% of normal at mid-March, and then we got the one particular storm on the 14th and 15th. And I think some of it happened on the 13th as well, towards the end of the day, and then all the way through the rest of April, just kind of lumping things together. We got a real good boost there in those mid-March storms to early April. And to help display the change that we saw over that kind of 3-week period, you can see that most of the points here that I'm showing were showing relatively high values. You can look for those deeper blues. And in this case, the way the mathematics work out, the red being negative actually it also winds up being a boost, mainly mathematically, because the sites were have a tendency to melt off in some of these locations. So please just look at the red as synonymous with the blue. There were some pretty good boosts in in those mid-March storms. So here again, as I pointed out earlier, in the state of Colorado, we really saw good boosts at the end of January and then the middle of March, and we were able to sustain those snowpacks with good accumulation through the majority and kind of the heart of winter. So where are we looking? How are we looking right now? This is as of yesterday morning when I updated the presentation. Snowpack in the northern half of the state is pretty much right at normal. Whereas in the southern half of the state, we did see a dry period, and I'll highlight that here in a few more slides. We did see a dry period since the beginning of April, when that storm pattern kind of ended in early April. And Peter also alluded to that things have dried out, and it's been pretty consistent across much of the state. So as of today, or yesterday morning, I should say, excuse me, statewide snowpack is 95% of median. This table that I built here is basically showing not only where we are as of yesterday morning, so you can see in this rightmost column, this is where snowpack was as of yesterday morning, but I also wanted to show where snowpack was at the peak of the snowpack across all of the basins, and that's here in this second to rightmost column. Explaining it a little bit more, the second column here is the date in which these basins normally peak. Now, there's a lot of variability to that, and that's completely normal. But if I had to pick one day, this is what the statistics point out is the normal peak date for each one of these basins. The column next to the right here, this is the normal peak value that we see for those basins, and the amount of snow water equivalent based on the snow tells that we have in those basins and the values for those days. In this fourth and fifth column, we have the peak date that we observed this year for these basins. And again, you know, different sites based on being at different elevations peak at different times, but this is the numerical average for those peaks. And so you can see that for the most basins, they peaked out relatively close to normal. So, you know, the combined San Miguel, Dolores, Animas, San Juan basins peaked out one day after when it typically does, as did the Upper Rio Grande. The Arkansas was right on target there, and the Gunnison was 2 days late. As for the other basins, the Yampa White and Little Snake, Colorado Headwaters, North Platte, Laramie, and South Platte, all of those basins have shown that we may have peaked, but these basins are either further north or higher in elevation and can tend to peak a little bit later, usually do, specifically the North Platte and Laramie and South Platte. And so I put an asterisk by those because there is a chance, if we do get future storms, that those basins could see another higher snowpack peak. In many of these basins, they sometimes tend to not melt so quickly and kind of stagnate for a little bit as the snowpack continues to warm up with some of these warmer days and potentially warmer nights. And then the snowpack will melt off a little bit later. In doing a quick scan of some of the sites in the northern part of the state, we are showing that the snowpack is not really accumulating as quickly as it did earlier in the winter, but this is completely normal for it not to see a whole lot of additional snowpack added, because at the lower elevations, the snow is tending to melt, whereas the higher elevations, it's hanging around, and the majority of our sites do sit at those higher elevations to capture a little bit more information. So long-winded way of saying there is a chance, but based on what Peter was saying, we're not seeing a great chance of future precipitation, one that would really drive a new snowpack peak, but we never know, things can happen. So we'll keep an eye on the situation there. Good part is overall, snowpack did peak out near about normal. It's a little bit below normal, but being this close to normal in this second to furthest right column is that representation. So the Arkansas did see a peak slightly above its normal peak, which is great. Statewide, we were at 98% of that maximum peak. And, you know, things could change a little bit, but more than likely, they probably won't at this point. So that's good for a water supply standpoint because, you know, snowpack drives, you know, about 80% of our water supply, as much as 80% of our water supply here in Colorado. Okay, so just kind of looking at the breakdown of snowpack in these smaller basins. Earlier I showed you, or wait, did I? Sorry, maybe I have yet to show you that. Nonetheless, you could see here, looking at the smaller basins and with the individual sites indicated by the dots on this map, that snowpack is largely at normal in the northern and central basins, and then below normal, as we have seen a fair amount of melt at this point in those southern basins. And you can see that just a number of the sites in the San Juans are already showing some lower values, as are some of the sites on the Grand Mesa. The Grand Mesa did not have a great snowpack this year, as it did last year, but it is also tending to decline as well. You know, Park Reservoir is kind of holding on to some of its snow, but these other sites, Overland Reservoir, McClure Pass, are seeing some pretty steeper than normal declines, and that would be melt rates for their snowpack. So going a little bit more into those peak snow values that we saw, here's the dates. Sorry that there's a whole lot of overlap on the peak dates in this map, but as you can see, as is typically the case, about April 10th is where we see the peak in the San Juans, right on time, as I mentioned earlier in the table. And then when you go further north into the main part of the Rocky Mountain front and whatnot, you see that some of those higher elevation sites, you can see the 421, the 420s in here, those are those higher elevation sites that typically hold on to snow a little bit longer, whereas the lower elevation sites peaked out in late to mid-March, and that can be completely normal. Looking at the snow depth values across the state, and into southern Wyoming there, I think it's Sand Lake had 124 inches of snow depth there. That was one of the highest in the state. Otherwise, relatively normal snow depths here, distributed from, you know, about the 40s range on the low end to around 100 in some of those northern sites. And as I mentioned in the table earlier, statewide, snowpack peaked out at 98% of its normal peak. These values here are actually with respect to the trend line or the median line on there. So these values actually indicate a little bit higher than the actual average of the peaks. So just distinguishing between those two. But nonetheless, as Peter mentioned, we had a pretty good snowpack this year, relatively close to normal, not right at normal. We'd like to see a little bit above normal, but that's not exactly what we got. So going to highlight a few of the individual larger basins in the state to show that snowmelt that we're seeing, as well as just kind of highlight what happened with those snowpacks earlier on. So in the Rio Grande, again, those southern basins didn't have a great snowpack through the majority of the year. Saw the storm cycle that we had in mid-February, early February, gave a boost to the upper Rio Grande, and then saw another boost here at the end of March, which brought the upper Rio Grande to near normal, at least compared to the trend line, but not compared to the average of the peaks. That's okay. It's still pretty good. It bodes a little bit better for the stream flow runoff. However, the early and relatively sharp melt that we are seeing will wind up probably having an impact on the stream flow forecast when we run them here in about 8 days. actually, sorry, I should say, yeah, we should be running them in about 7 days. So hopefully we will get a little bit more precipitation and see a boost here, the black line being this year and what we're seeing so far, and we'll get back on track for some of those melt rates, which it's typically, it is pretty normal to see melts that happen like this, and then you do get a storm and kind of bump it up, just like here in what happened last year. And that's what kind of helps sustain this slightly slower, or I shouldn't say slightly slower, I should say the average melt. But if we don't have any of those storms, this melt rate will usually maintain and just keep its pace, much like it did here in 2020, where we didn't get any additional storms. So we're really at the mercy of future weather. So the upper Rio Grande is seeing melt. We'd like to see a storm or two, but we'll just have to cross our fingers. Moving on to the Arkansas, where snowpack was the highest, you can see that it did, in fact, exceed the average of the peaks. But here we have hit a pretty steep melt. And much as you see here in 2023 and 2003, we'd like to see those little bumps that help, bumps being additional storms. And usually they are pretty significant storms. But we're at this point, we just haven't seen those, and hopefully we will, to slow down the snow melt. Snowpack in the South Platte, as I mentioned earlier, is kind of hanging on and stagnating, which again is normal. You can kind of see that in the green median line in the back. It seems to kind of plane out and not to continue to accumulate too much more snow. And that's what it's doing here. And I would anticipate that it will hold on for at least another few weeks, or excuse me, I should say maybe week or two before we start seeing any melt. Of course, if the temps get warm, then we can see some melt. But right now, snowpack is 101% of normal in the South Platte. And I threw just 2021 and 2023 in here as years that were relatively similar to what we're seeing this year in the South Platte. And finally, the Colorado headwaters, snowpack is 97% of median here. We are seeing a decline in those lower elevation sites. As I mentioned on the Grand Mesa, we're seeing a decline there. The upper end of the basin, we're not quite seeing the decline there, at least at the higher elevation sites. Snowpack is still holding on there, as it typically is. Okay, moving on into precip. Again, highlighting the set of storms that we saw in late March, very early April. There was a big benefit to the southern portion of the state. A lot of good precipitation there. The northern half of the state saw okay precipitation, slightly below normal to near normal. But the southern half of the state is the one that really benefited from those storms just last month. Precipitation is 98% of normal. Forgive me, it's not 98% of the month-to-date precipitation, but this is 98% of normal for the year-to-date precipitation. And again, building on what Peter mentioned, precipitation through much of April, however, has been quite dry. It seems like it was a real, the switch was on in late March, and then the switch was turned off in April so far, particularly in the southern half of the state. The northern half of the state has done all right. We got that storm this past weekend, which helped out a bit in a few basins, but not where we needed it, mainly in the southern half. So here again, statewide precipitation is 98% of median as of today, largely looking pretty good across much of the state. But as I mentioned earlier, the southern half of the state is drying out, and we're really starting to see that in some of these yellows here, not just in the greater basin, the San Miguel, Dolores, San Dimas, San Juan basin, but also in those sites. And then, excuse me, it seems, I put this slide in there to just highlight what's going on in the smaller basins. If you have particular basins of interest, you're looking at your particular area. Some of those larger basins that I showed in the last slide are just to give a better idea for summary to kind of encapsulate everything. Okay, Looking at the time series, state of Colorado, again, below normal for the beginning portion of the winter, but then the latter portion of the winter, we did see a bit better precipitation statewide. It was a little bit above normal, and you can see that we passed that normal line. Sorry, I'm having trouble getting my cursor to stay up. That median line is right here, the smoother one, and you can see that we kind of were slightly steeper in the positive direction there, which means we got slightly better than normal precipitation. So in the San Miguel, Dolores, Animas, San Juan combined basins, precipitation is 87% of normal. And here you can see that with the black line again, never have gotten above that median line, but comparing relatively closely to 2022 and 2020. In that basin, in the combined Yampa White, Little Snake, showing the upper end of what we're seeing across the state for the major basins, running a little bit above normal at 107%, but still quite close to normal. Okay, reservoirs. Reservoirs across the state are 99% of median. Fortunately, over the last year, reservoirs have been able to track pretty close to normal. And like Peter said, thanks to last year's snowpack, really wound up helping out and making those soil moistures where we need them to be and charging those up. We did have a bit of a drier fall, which did impact some of those stream flow forecasts, and you'll see that here in the coming slides. But fortunately, reservoirs have held relatively strong. Another way of looking at those reservoir values, you can see most of them are at or above normal. And excuse me, these are not particularly reservoir values specifically, but they are still those basins or the combined basins in the state and how they add up basin by basin. This is a graphic of reservoir storage as a percent of capacity, the lighter green being last year's value and the aqua color being this year's value. And this is relatively normal that they are below capacity because runoff, the heart of runoff has yet to happen, although it is started in those southern basins, the upper Rio Grande and the combined San Miguel, Dolores, and San Juan basins. We have yet to really see runoff get into full swing at this point, and so usually reservoir operators draw down their reservoirs in anticipation of that runoff. Any of the providers and reservoir operators can correct me when we're done with the presentation, but I'm the specifics of managing reservoirs are not really reflected here in this graphic, but I think it is good to point out that reservoirs are sometimes drawn down before runoff happens. Okay, another way of looking at those reservoir values. So what I did here for the next 4 graphics, I believe it is, I took a screen capture of where reservoirs are right now, which is indicated here on the rightmost portion of the graph, and then where they were a year ago. I made sure this text box was in there, so to compare where we were last year to this year, and then you can see this is the historical trace of where the reservoirs have been for all of the combined reservoirs in the particular graphic. So this one is the state of Colorado, as you can see right here. Reservoir storage, again, 99% of normal, just below, and higher than it was last year at this point. And I'm sorry, I'm not sure if you just saw the little pop-up that came up on my screen. My battery is running low. I thought it had a little bit more life than that, but I guess not. So I'm going to speed this presentation up a little bit in hopes to avoid shutdown on you guys. Moving on into the combined San Miguel, Dolores, and San Juan basins, reservoir storage is below normal here, but still above where it was last year at this point, but near about where it has been over the long term. Looking at the upper Rio Grande, reservoir storage is the best in the state here, I believe, and it is above normal now and above where it was last year at this point. And then finally, looking at the Colorado headwaters, reservoir storage has continued to creep up here. And I think I put that, oh no.
Uh-oh. I think we might have lost Brian. Let's see. Give me 1 second. Okay. Seems like we might have lost Brian. His computer probably died, but um, let me message him. But in the meantime, I know that we have Jeff Deems from Chasm here. Jeff, I made you a co-host. Hi.
Good morning.
Hi. Maybe you could do your presentation now and I can message Brian to see if he'll come back.
Sure.
Okay. Sounds great. Thanks, Jeff.
All right, sharing now. Okay, thanks, Emily, and thanks, everyone. Sorry, we didn't get to hear the end of Brian's talk there. Hopefully he can get back on. I am here representing both Airborne Snow Observatories and the Colorado Airborne Snow Measurement Program, or CASM, with an update on 2024 water year snowpack conditions. Just by way of brief introduction, really what we're after is working in concert with the data sources that Brian was talking about, that the NRCS maintain, to try to monitor our biggest reservoir, the mountain snowpack. The snowpack in the mountains is incredibly complex across the landscape. We're looking here in the background at a snow depth image from the Airborne Snow Observatories in 2019 in the Elk Range. What ASO can provide and that the CHASM group seeks to expand and sustain statewide is this spatial perspective of the mountain snowpack across the landscape at high resolution and high accuracy. These data covering entire watersheds work in concert with the SNOTEL network and the manual snow courses from the NRCS to really provide a four-dimensional view of our mountain snowpack reservoir. The two SNOTELs in this image are monitoring continuously and providing continuous information, and combined with snapshots of the entire snowpack in the watershed from ASO, we can constrain our snowpack and hydrology models to produce the most reliable forecast going forward. ASO started in 2013 as a NASA Jet Propulsion Laboratory project, combining a couple of remote sensing instruments on a twin-engine aircraft, a LiDAR and spectrometer, to measure snow depth and snow albedo and estimate snow water equivalent across entire watersheds. These measurements are combined with physical modeling of the snowpack and hydrology, and done in a unique rapid operations mode to provide low latency data products. In 2019, the program emerged from JPL to Airborne Snow Observatories, Inc., and continues to provide these same services. In 2020, the Colorado Airborne Snow Measurements Program was formed with leadership from the CWCB and a number of water providers and water agencies statewide, with the mission to expand and sustain the ASO measurement program throughout the state of Colorado, and to support integration of this new data resource with operational forecasting and water management. The CHASM website is coloradosnow.org. Please visit that site for news and updates up to date, as well as a report on program expansion and a bunch of other great resources there. So please visit that resource for more information. A couple of highlights in particular: in 2022, CHASM received a pretty hefty state water plan grant to scope and begin expanding the program statewide, which added some more coverage of different basins in the state, and really deepened and broadened the outreach and data workshop efforts from that group. Looking forward with CHASM, in addition to coordinating funding and operations year to year, the group is working to expand state and federal funding opportunities to expand the program and to continue collaborations with forecast agencies and other data users. This year, in 2020, water year 2024 in the state of Colorado, we are sustaining and adding new basins to the portfolio. This is achieved with funding support from local to federal levels, local and regional water supply, water conservancy districts, municipalities, et cetera, funding from roundtables and the state WSRF funds. CWCB projects bill has become a crucial resource for this program. And then some federal funds through USGS, Bureau of Reclamation, Department of Energy, and new this year is the Upper Colorado River Commission providing some funding. For all these basins, we're producing runoff forecasts with the WRF Hydro model developed at NCAR that we now run in-house. And again, long-time engagement with the CWCB on that effort, beginning down in the Rio Grande Basin in 2015. The Colorado Basin River Forecast Center is also producing experimental forecasts by ingesting ASO data. And then, as I mentioned on the last slide, the CHASM group is really serving as a nexus for stakeholder coordination and engagement throughout the state. So this year, we've got 3 flights in the Colorado headwaters above Windy Gap with some funding from Bureau of Reclamation enabling that expanded program. We've done 2 of those, 2 check marks by that basin with a 3rd to come. 2 flights in each of Dolores, Conejos, East and Taylor Rivers, the Roaring Fork, the Yampa and Elk, that's new terrain this year, and then the Blue and Upper South Platte. All of those have received 1 flight except Blue and South Platte, which we're working on getting this week. And then the Northern Front Range is funded for a single flight this year from Clear Creek north through the Middle Fork of the Poudre. We've got most of that done so far, still waiting on a weather window, hopefully maybe tomorrow to get Boulder and Clear Creeks. All of these data sets are hosted on the ASO website, listed there, data.airbornesnowobservatories.com. All right, some results from this year. I'm going to highlight a couple of basins they sort of exemplify a couple of different issues for the sake of time, and then conclude with some more overarching thoughts there. So first up, let's look at the Colorado River headwaters. Again, this is above the Windy Gap Reservoir. We've had 2 surveys so far, one in mid-March, one just about a week ago, April 14th. And you can see, sorry, let me move my little Zoom screen here. We can see the tabular data from the full domain and subwatersheds listed in 1,000 acre feet top right here. I should note that all of these information, all the images on this slide come from our flight survey reports, which are available emailed out. If you're on the email list, please contact us to get on that if you're not, and also available via our website. And some interesting changes over the past month and a half here from mid-March into April. Some parts of the basin remaining about the same SWE volume. For example, above Lake Granby, almost exactly the same. Some increases up in the smaller basins, up in the Fraser, and then a pretty strong decrease in Willow Creek. A lot of that's reflected in the sort of reddish plot bottom center there. So this is the change in water equivalent volume by aspect and elevation. Imagine you're looking down on the top of a conical mountain with the highest elevations in the center, lowest around the edge, and then the different slope and aspects around the perimeter. So we're seeing there the blue color showing increases in snow water equivalent between these two flights, mid-March to mid-April, at the highest and north-facing elevations, with strong melt out at low elevations on all aspects. A little bit of what this looks like spatially. So here is looking at Willow Creek. That's Willow Creek Reservoir, bottom right. Windy Gap Reservoir is just off the screen, bottom center. Willow Creek Pass, top left. And we're showing snow depth here in 0 to 0, lowest in the reds with 2 meters plus in the deepest blues. Already in March, we're seeing some melt out on south-facing slopes. And by the time we get to mid-April, a lot of melt out occurring in Willow Creek. Most of this area, of course, is within the East Troublesome fire scar. The red line you can see around the edges of this image are the fire perimeter. So not much forest sheltering the snowpack there, and combined with some dust on snow, enhancing snow melt rates there. If we look at the Fraser, by contrast, here in mid-March, that's town of Granby, bottom right, and then looking up towards Fraser, Winter Park, Berthoud Pass, top center of the image. So mid-March, snow depth here, and then mid-April. So, pretty good melt out and decreasing snow depths at low elevations. But it looks pretty static up high. In fact, you can see a little bit of accumulation that was noted by the summary graphics before. By way of comparison with last year, which is fresh in our minds, so this is April 14th this year. Here's April 16th last year. So last year at this time, there was a good bit more snow at low elevations, as well as in the middle elevations in the forest. Notably, less snow last year up on the highest peaks, a lot more wind effect, I think, if I remember right. If we compare the volumes from 2023 to 2024 in the 3 subbasins for Windy Gap, we're seeing pretty big decreases from last year, not unexpected, given how what a banner snowpack we had last year in Willow Creek and Granby. But we're actually seeing more volume in the Fraser this year than we were last.
Oh no. Looks like we lost Jeff as well.
I'm back. I'm sorry. I'm not sure what happened.
Okay.
Get my presentation back up.
Okay.
Apologies again. All right, we're back. Okay. I think I was right there. So we have seen some pretty substantial melt since mid-March. The differences between our March flight and last year were even greater in the Fraser. I think it was 16 or 18% more snow in March than last April. So interesting to see those dynamics year to year as we're measuring the full snowpack volume, and to see how that plays out in the forecast. Moving to the southwest in the Dolores River, we flew on April 4th this year. And some of the basin and sub-basin summaries there. In this case, I want to call attention to the bottom right plot, which is snow albedo by elevation in the 3 different wavelength categories: near infrared, broadband, and visible. Visible in particular shows the effects of dust on snow. And as we're getting down below, say 11,000 feet, again, this was April 4th, in the Dolores, pretty strong reductions in albedo, showing the presence of desert dust on the snowpack, reducing the snow albedo, increasing solar absorption, and enhancing snow melt rates there. The Dolores, I think, is an interesting example of where We're seeing a good bit less snow in the basin than the stations would lead us to believe. Here's some, again, comparing to last year, since we haven't yet had our second flight in the Dolores this year. This was April 6th last year. Lizard Head Pass off to the right. You could see the highway through the center of the image there. 0 to 2 meters is the color scale. Last year compared to this year, pretty dramatic differences in the spatial distribution of snow, with meltout already occurring even before April, comparing those 2 years. Another view, Lizard Head top left, Black Mesa center left, looking off to the La Plata's top right last year, and then this year, pretty dramatic differences and large areas of the basin already melting out on April 4th. So moving ahead to how these data integrate with runoff forecast efforts, the ASO pipeline supports runoff modeling and forecasting through our own pipeline, through the Wharf Hydro model, coordination with the river forecast centers and other forecast entities out there. We work with lots of different irrigation districts, et cetera, that run their own internal models. I'll compare two for each of the basins I've talked about here. So the Colorado Basin River Forecast Center experimental forecast, where they're replacing the snowpack in the Snow 17 model with the ASO data. And then our ASO Wharf Hydro forecasts, where we insert the ASO SWE into this fully distributed physically based model. And let's look at those two areas. So again, Colorado River headwaters, we're looking at 3 different sub-basins here. The one thing that we saw, especially with the Wharf Hydro snow, but I think this is pretty consistent with all the different snowpack estimates in this basin, volume estimates, is that the ASO flights in mid-March provided a substantial bump up in the amount of SWE represented in the basin, highlighting, I think, some inadequacy of some of the larger scale precipitation products to represent the snowpack up there this year. Looking at the Fraser at Winter Park area, on the left, this is the time series of River Forecast Center forecasts, and the blue dots towards the right end of that graph show the ASO experimental forecast with the 10, 30, 50, 70, and 90% exceedance values by the dots. And those are in the table at the bottom there too. So you can see in this case, not much change to the ESP forecast by the insertion of ASO data at this above the Winter Park gauge. And slightly higher forecasts from Wharf Hydro at this point. Actually a good bit higher, about 30,000 acre feet compared to 22. Moving over to the Granby Reservoir inflow. In this case, we can see that the ASO data bumps up the RFC experimental forecast a good bit, from 210 to 237,000 acre feet at the 50% exceedance. In this case, the ASO, most recent ASO forecast comes in around the same range, about 222, accounting for some recent snowfall there. And then over into Willow Creek, a slight increase from ASO data there in the RFC model, and largely in agreement with the Wharf Hydro forecast for that basin. Down to the Dolores, the April 4th flight provided a pretty strong downward correction to the RFC model, in this case from 160 down to 125,000 acre feet. And with the Wharf Hydro forecast coming in even lower than that, at about 107 currently. So I think the Dolores in particular, as I mentioned previously, the ASO volume showing that there's a good bit less snow in that basin than would typically be inferred from the SNOTEL data, and might be a particularly acute management challenge in the Dolores this year. So in summary, statewide, we're seeing varied performance on how the ASO data compares to what we would expect from the SNOTEL percent of normals. Some basins like the Dolores providing a pretty strong downward correction. Other cases, a pretty big boost to the snowpack from the full basin measurement. Lurking out there is a pretty strong dust layer that occurred from a dust event that occurred in early March. It's exposed at lower elevations and is progressively exposing at upper elevations. I'll echo the prior two presenters to hopefully the incoming storm gives us a good snow cover up high to cover up that dust and stave off some of the melt. Another thing we've noticed is atypically low snowpack cold content this year, and that's the amount of energy it would take to warm up the snowpack so it's ready to melt. It seems that our warm spells in January and February added a bunch of heat to the snowpack, and we don't really have our typical Colorado cold snow buffer to delay snow melt this year. That's factoring into some of the increasing melt rates that we've seen so far, and combining with the dust to really enhance that snowpack ablation. As Brian was mentioning, I think we're really at the whim of the incoming weather to determine how fast our snowpack is gonna run off right now, because it's poised to come out pretty quickly. Last year we had big dust, but we had a pretty cool and wet and snowy spring that delayed the runoff. So hopefully, let's hope for another wet spring to keep the runoff slowed down. We do have upcoming CHASM ASO surveys throughout May, with the dates varying on how the snow cover evolves and the needs of the individual water managers. Please visit our website, airbornesnowobservatories.com, and the CHASM website, coloradosnow.org, or email me directly at the address at the bottom there if you have any further questions. Thank you so much.
Awesome. Thank you so much, Jeff. If anybody has any questions for Jeff, feel free to ask them.
Oh, and Dave Gotch just put a note in the chat correcting one of the numbers I gave there. So thanks, Dave.
Awesome. Cool. Well, thanks for all those great, as Peter said in the chat too, I agree with him. Loved the snow imagery. And thanks for popping on this meeting and providing that information. It's really valuable and just a really cool technology. So thanks again.
Awesome. Thanks, Emily.
Yeah. And it looks like we do have Brian back. Brian, if you'd want to finish up your presentation, that would be great.
Sorry. Hey, Emily, can you hear me now?
Yeah.
Okay, awesome. Sorry, I did not think my computer was going to die sub 60 seconds. That was way.
No worries.
Got a bunch more. And I'll share the rest of my presentation. All right. So moving on into streamflow forecasts. You guys got the presenter slide, don't you? Well, we'll just roll it because I'm going to make it fast. Streamflow forecast across much of the state are looking, they're ranging from about 70% of normal to a little bit above normal, depending on the basins that you're in, and many of the information, much of the information that I provided earlier. So in the northern half of the state, we're anticipating runoff to be closer to normal. Southern half of the state, based on the April 1 forecast, runoff is supposed to be below to slightly below normal. Now, as we mentioned, and Jeff got into in his presentation, there's been some developments since our last forecast period in April 1. As we approach that May 1 forecast period, there has been dryness, particularly in the southern half of the state, and that will certainly have impacts on that May 1 forecast period. I would assume that we're probably going to see a decrease, but we have yet to, moreover, get through the rest of April and see exactly what the rest of April is going to provide us, and really get an idea of what's going to happen through April, and then what the statistics are based on that May 1. So right now, this is what we're seeing for April 1. Come May 1, I would anticipate we're going to see below or a slight decrease in these forecasts here in the southern portion of the state, but we'll just have to see what is yet to come. I'm hoping most people are familiar with these graphics because I'm not going to get into them, especially in the light of time. But here in these southern basins, as I mentioned earlier, even what we've seen through the beginning part of April, runoff values and snowpack has been below normal, and that's what we're seeing here. So most of the bold, or the 50%, the most probabilistic outcomes for those forecasts are below normal, and normal is indicated by that light gray line here in both of these graphics. So both in the San Miguel, Dolores, Animas, San Juan, and the upper Rio Grande basins, we previously had anticipated below normal runoff. And now that we're seeing these dry conditions through the majority of April here, I would bet that these forecasts are going to trend downward a little bit more. And then finally, into some of the more favorable basins, or let's put it this way, the northern half of the Arkansas, again, the bold values are above the median line, the gray line here. So those runoff forecasts look a little bit better, but the southern half of the basin is drier. And in the Yampa White and Little Stake basins, many of those forecasts are looking to be above normal. So very short summary. Snowpack is slightly below normal, but still close to normal. It peaked pretty close to normal at 98% across the state. The northern basins are looking better than the southern basins, and the southern basin snowpack is melting faster than normal. Hopefully we will see a storm or two that will slow down that melt, but you know how future precipitation is. We can't always count on it. Reservoir storage is looking near normal at 99%, and stream flow forecasts are again below normal in the southern half of the state, probably trending downward a little bit more based on the dryness that we've seen over the course of April. And that's all that I have. And sorry for that hiccup there.
Grace, thanks for finishing up, Brian. Any questions for Brian?
Easy enough. Thank you.
All right, yeah, cool. Well, yeah, thanks again, Brian, Jeff, and Peter. Now, I guess if we want to open it up to everyone on this call, if you're a water provider, manager, municipality, if you have any updates for us that you'd like to share on how the local conditions are in your neck of the woods, feel free to go off mute or provide it in the chat.
I just have a quick question, if that's okay.
Yeah, go for it.
I just dropped this snow to flow chart into the chat, which I really like to use in the San Miguel because it uses a different array of SNOTEL sites, and it has runoff charted on the other y-axis as well, so you can sort of look at analogous years to try and figure out what to expect. But it's just like the regular NRCS SNOTEL SWE charts, but it hasn't been updating this year. It was like stuck in January for most of the season, and now it's like moved into, I think, mid-February, but I was just curious because again, for us, that's like it sort of excludes the Uncompahgre Plateau and just looks at the upper basins. So it's sort of much better to be able to isolate those two areas. So I don't know if anybody from the NRCS or other agencies would know what's going on with that chart.
I don't know exactly what's going on with that graph. I do know that my colleague here at NRCS actually created those graphics for the Bureau of Reclamation, and I know he still has some connections there. I don't know if Bureau is updating those or not. At one point, I thought we at the NRCS may be putting out some of those graphics, or we might be experimenting with them. Let me put it that way. And I'm not sure what the status is of our potential to be putting those out. So if you give me a chance, I can reach out to my colleague and see what information he has, if you don't mind some delay in getting a response from me.
Yeah, that would be awesome. Yeah, and at one point, the same map that is hosted on the BOR website was also on the USDA website. I was looking for it earlier, and it doesn't seem like it's there anymore, but it's the same exact thing with all the stations and those snow to flow charts. But yeah, let me know. That would be great. Thank you.
Yep, you got it. Great question. Thanks.
All right. Okay, I see Highlands Ranch storage capacity in the chat. Thanks for putting that in there. Last chance for anybody to report out on local conditions. All right, well, hearing none, that concludes today's WCMC meeting. Thank you all for joining. Again, thanks to Peter, Brian, and Jeff. And just a reminder that next meeting we'll have a hybrid option at the CSU Spur campus in Denver. So maybe hope to see some of you in person. Thank you.